Hello, everyone. Welcome. Today, what we are going to be working on is our first graph of economics. And this graph is called the PPF or PPC. So, what exactly does that stand for? Production, possibilities, frontier, or if it's called PPC, curve. Does not matter to me. I spelled frontier wrong there. That's okay. All right. Um, if you remember what we were talking about before, one of the key central concepts of economics is this idea of scarcity. Okay. And the fact that we may have unlimited wants, but we can't have unlimited things. Okay, there is a matter of scarce resources, and a lot of economics is trying to figure out how society allocates these resources. Okay, so this production possibility frontier or curve, and this first graph is playing with that concept. Okay, so let's get into it first. All right, so imagine that we are a country. All right, we're going to be Sweden here, all right, because I like Sweden. And Sweden can only make two goods, as I mentioned here. Okay. They are going to only be able to make guns or butter. Now, if we were in class, I would have you choose your own goods, and we choose them, but guns and butter is a classic economic example. All right, so let's say guns or butter here. Not the most accurate for Sweden, but let's say Sweden can make 50 guns, but if they make 50 guns, they can make only zero amounts of butter. Okay. Well, let's say they make less guns. If they make 40 guns, now they can make 40 butter. Let's say they make 10 less guns, they can now make 80 butter. All right. You guys can get the pattern here a little bit. All right. 10 or 160. All right. And if they made zero guns, they can make 200 butter. Okay. If we know this information, we can now take this and graph this. All right. So all our graphs in economics are going to have a XY. All right. It's going to be very important that we always are labeling our axes. All right. So I'm going to put butter here on the bottom. I'm going to put guns up here. All right, and I can graph this. It does not matter too much to me how to scale it is, at least for this. So I'm just going to end up saying, hey, here at our y-axis, an intercept would be 50. And with this, this is going to be a straight line here. Okay. And thus, they can make 200 butter. And this is our first graph. This shows us, all right, what Sweden is capable of making. All right. Now, with this, we have more information. All right. And more things that we want to talk about. So, the first thing I want to ask is what is the opportunity cost of making butter for Sweden? And I could ask this in the sense of like, hey, we could do this in for if they go from making 50 to 200. All right. Generally, when I'm being more vague with this, we're talking about per unit. All right. So, what is the opportunity cost of making just 1 unit of butter? All right. Well, if you remember, opportunity cost is talking about what you must give up for what you get. So, what must they give up to make butter? 50 guns to get 200 butter. Or they have to, if they want to go from guns to butter, they have to give up making those 50 guns to get the 200 butter. That simplifies down to 1/4. Okay. Now, with this, though, we're not done yet. All right. They aren't just giving up 1/4. What are they giving up 1/4 of? 1/4 guns. Okay. And likewise, we can reverse this. What is the opportunity cost of guns? All right. Well, if they wanted to have make guns and stuff, instead, they would have to give up 200 butter to get 50 guns. Oh, not 500. All right. So for butter. And this is our first graph, our first PPF PPC. One thing to note about this one specifically is if you notice we drew this as a straight line. All right. This is going to show that there are constant opportunity costs because no matter where I was, whatever point I'm at, um, it would always be the same opportunity cost to make one additional butter or one additional gun. All right. Let's take another, and then we'll get into a little bit more information. Okay, so my question here is going to be the following. Let's say you have 50,000 units of labor hours. Okay. And some information for this problem is you can make computers and wheat. All right. One computer is going to take 100 hours. All right. One, let's say, ton or bushel of wheat. One wheat is going to take 10 hours. All right. My question for you here is I'm going to ask you to pause the video and can you now just make a PPF with just this information that I gave us? All right. And then with that, what is going to be the opportunity cost of producing wheat and what is going to be the opportunity cost of producing a computer? All right. So pause the video, give it a try, compare with someone, and then go. All right, let's draw this first graph here now. Or sorry, second graph. So, all right, I'm going to put wheat on the bottom, computers on the y-axis. If I was to use all of my labor hours on making computers, how many computers would I be able to make? Well, hopefully you can do that math. 50,000 divided by 100, I could do 500. If I was to be able to use all of my labor hours and put it onto wheat, 50,000 divided by 10, I would make 5,000 wheat. And with this, I can just make a straight line. And that's it. That's all I need. All right. I don't need all the other information. I know many of you maybe try to go with all these different points to make sure that it's even. I don't need that. I need clear axes, I need clear curves, and I need clear points of interest. So in this graph, what's interesting is the 500 and the 5,000. All right. Other graphs down the road will be other interesting points. All right. Now, let's answer those questions. What is the opportunity cost of wheat? Well, if you want to make wheat, all right, you're going to have to give up 500 computers to make 5,000 wheat. What is that getting simplified down to? All right. That 1/10. All right. And 1/10 of a computer. All right. So yes, that maybe seems a little silly. You can't make 1/10 of computer, but yes, you can. You could get 1/10 through of the way of making that computer. All right. Likewise, what is the opportunity cost of making a computer? Well, you'd have to give up 5,000 wheat to get 500 computers. So 10 wheat. Okay. So point out a couple new things here. So that first graph, what I made it in the following way. Let's just go with, again, wheat and computers. I don't really need there, but it was a straight line, if you recall what I said here. All right. So the opportunity cost for this, whether you're making wheat or computers, was always the same. So we call this a constant cost, constant opportunity cost PPF. All right. And I'll put this in a different color here because that was a constant opportunity cost. Now, I could ask us to draw it, or I could draw it differently. And that's what I will do here with a bowed out, all right, curve. Okay. Now, why would I do this? Because this is going to be more realistic. All right. In the real world, you have economies of scale. It's not necessarily always going to be a one-to-one. So, what is going to be the opportunity cost in this situation? Well, it's not constant, all right? Our slopes here is not constant, all right? If I am going to want to make more wheat, let's say in the beginning, I have to give up just a little bit of computers to get a lot more wheat. Towards the end, as I start to produce more, I'm going to have to give up a lot more computers to make more wheat, all right? And that's as I was going from left to right. But if I was going right to left on this curve, the same thing would happen. So what we would say here is that our opportunity cost is increasing. And it is increasing for both computers and wheat. All right. So that's the next bit that we just did. We still have two more pieces of new information. So I'm going to erase this and then bring up a couple new things here. So let's start with our plain PPF. Within computers. One thing to note, if I don't ever specify, all right, whether constant or increasing that I want you to draw for the PPF and opportunity cost, it doesn't matter to me. All right, so I'm going to draw 3 points on this graph. I'm going to draw point A. I'll draw point B. Whoop, that's not as good of a pen. And then I'm going to draw point C outside of this. All right, so A is inside within the curve, B is right on the curve, and C is outside of it. Okay, so what I want us to think about here is what do these points represent? What would be, they're obviously represent different combinations of computers and wheat, but they tell us a little bit more. If we are producing at a point of A, All right. Is that possible? Yes, it's possible. Okay. Would that be efficient, would we say? Would we, if we were in this society, would we want to be producing that much? No. It would be considered inefficient. All right. And why is that? Because we could produce more of either one. All right. We could produce more peers, we can produce more wheat, and we would be better off for that. All right. Part B here, we would say is efficient. Why? Because we're maxed out. We can't produce more. We could produce more of either one, but we are using all of our resources and those labor hours. And part C here would be not possible. Or I should say, not possible in this certain situation. Are there situations where you could produce that far? Yes. Hopefully you can think about what they were. Well, one, let's say our country grows. I should say not possible without, and what is it without growth? Or we'll talk about this later. What do countries do? Not countries aren't necessarily silos, but trade would be not possible without growth or trade. So that's a little bit more about our PPF. We're going to do one more thing here with this. All right, we talked about possibility without of something going for growth. All right, a economy can grow, it can shrink. All right. Well, let's think what is going to shift that PPF in or out. Okay, so we will say this now here. We are going to do our shifters. Oops, shifters of a PPF. All right, what is going to cause this to completely grow and everything grow out or stay in? Okay, all right. All right. So normally I would have you think and talk with people. Hopefully you can think and in your own here and talk with those around you before. Um, but let's get into it. First thing for us would be changes in our population. All right, think about the computer and weed example. If I have suddenly a lot more people, or I have people migrating out of a country, I'm going to have more labor hours or I'm going to have less labor hours. Okay. So that'll be our first one. Our second one is going to be changes in technology. All right. Let's say we now suddenly invent some tools, capital goods here, that's going to make it easier and more efficient and quicker, any of those things, to make computers or wheat. All right. You would be able to make more. Or if we had, let's say changes that go backwards, you could make less. We don't have many examples in society of, you know, changes in technology that are worse for us in terms of production, but that is one. All right. All right. Next one, let's say change in resources. So that could be quantity or quality of resources. All right. Let's say suddenly, I use this, and this is kind of talking about those factors of production of land. If we end up having the Louisiana Purchase, you suddenly expand the U.S. and double the size. All right, you're going to have a lot more resources. You're going to have the ability to be more productive. That doesn't mean you're going to be more productive right away, but your production possibilities, the total possibilities that you have are higher. All right. Quality of resources. If you are similar to the technology, if you discover a resource that's better, all right, in producing there. All of this comes down to um, changes in productivity too. All right. If we can be more productive, we can end up producing more or we can produce less. All right. And then remember the other things that could change things around are trade. I would put that as make things more beneficial. And that's really it, all. So have a great day and let me know if you have any questions. Hey, all. So I signed off a little early there. One more quick thing to add on PPFs. All right, let's go back and have our PPF here. All right, with wheat and computers. All right, I have the PPF. All right. With this, I talked about shifting. How do I want to demonstrate shifting? All right. Normally, what I would want to see is I want to see the original curve. We can call this PPC1, or you can just call it PPC. And I want to show some indication of clearly what is before and what is after. So here I'm going to end up showing arrows showing that, hey, this is clearly moved out. All right. Likewise, I could have done this the other way. All right. If we were shrinking our PPF and I could show, hey, we're moving inward. Okay. So it's really important when we are shifting in our graphs, you have your lines and curves labeled and that it's clear what was originally and then what came afterwards. Now that is it for PPFs and PPCs. Have a good one.